this week talking about our new unit systems. So today we're going to talk about a little bit of systems and like some not even application, the various types of answers for systems. We're not going to do this whole first question, but let's just practice writing equations from a word description. So we're given the context that people are going and buying hamburgers from a restaurant. You probably haven't done that for a year, so maybe we need practice at this. So at Burger Shack, so the description's up top here. For the first order, Deja charges $28 for 4 burgers and 2 salads. What is a possible equation that could represent that sentence? So remember, in this unit, for most of the cases, it's like one sentence is an equation, the second sentence is an equation, or the first part of a sentence and the latter. So what I've highlighted, how can we write that as an equation? Carissa. Right on. 28 equals 4b plus 2s. Be really careful with your s's because s's sometimes look like 5s. The second order, she charges $34 for 6 burgers and a salad. Someone other than Carissa, what would that equation be? Hafsa. Good, except it was 34. 6b plus an s. Cool. Not crazy. We can manage this. At Big's Burgers, Shelly charged $18 for a burger and 3 salads. Someone other than Carissa and Hafsa, what's an equation that could go for that? Camden. 18 equals 1b plus 3s. Good. Can I just write b? Yes. If you prefer writing 1b, write 1b. Totally your personal preference. Second part of that says $54 for 3 burgers and 9 salads. What's an equation for that one? Mateo. Right on. And the last one, Burger Haven. John charges $32 for 2 burgers and 4 salads. What's an equation for that? Go ahead, Wyatt. Good. Okay, and our very last one, $42 for 3 burgers and 6 salads. Charlotte. Good. So this would represent 3 systems of equations. There's 3 different kind of restaurants here, or 3 scenarios. Yes, they're related, but 3 different examples. We're going to skip rest of this page because I feel like they overcomplicate it, and we're just going to turn to the next page. I just wanted you to practice writing word descriptions into equations there. That was the goal. Okay, let's look at these first couple here. So we're just going to do a quick sketch of these graphs. So class example 1a, y equals x plus 5. What's the slope of that line? Slope is never x. What number is beside the x? 1, right? When there's not a number, it's just a 1. So I have a slope of 1. Where's my y-intercept? Plus 5. So the graph obviously isn't like labeled precisely. We're going to approximate these. But so this first one I'm going to do in blue. So I'm going to approximate plus 5 is here. 1 gives us a positive slope, so we know the direction, and we know it's not super steep. So I'm going to have a line that looks approximately like this. My second equation here is ever so slightly different. What's the slope of the second equation? -1. So what do we know about these 2 lines then? Good, they cross, they're perpendicular. The second line though, the y-intercept is at +1, so it's just ever so slightly up. So when I draw my line, I'm going to make it look as much as I can like it's 90 degrees, because it should be 90 degrees. We would say this system of equations has one solution. The 2 lines cross each other once. In grade 10, you will only come across a maximum of 1 solution. In grade 11, you'll see you can actually get 2 solutions or 3 solutions depending on the graph. We will only ever do a max of 1. Okay, let's look at B. What is the slope on the first equation for B? Good, 2/1. Crossing down at -8 on my y-intercept, so I'm going to have a line here. In theory, this is twice as steep as my previous lines. So I'm going to draw a line like this. What's the slope of my second line? 2. But now this one crosses at +6. Are these 2 lines ever going to cross? No. So if I asked you to solve the system of equations and you get a scenario like this when you graph them, your answer is actually no solution. You have to say those words though. Those 2 lines don't cross, so there is no solution. It may seem like a trick, but it's really not. Cam, did your hand go up there? Are you okay?
Yeah, so they both have the same slope.
Correct. Okay, so example C, my slope is 3 for my first one, crossing at -2. So I'm going to have a dot here, steepest slope we've had so far. Looking at my second equation though, can I look at that and just graph it? No. How do I graph that second equation? Slope intercepts. Good. So to do that, I'm going to solve for y. So I'm going to add 2 y's to both sides. So then I'm going to have 2y is equal to 6x minus 4. Then I have to divide absolutely everything by 2. Pardon me? I added 2 to both sides, which made it a positive. What do you notice about that equation? It's the same. So if I was to draw the second equation, I'm going to draw it right on top of my blue line, which means there are infinite points or infinite solutions. So in grade 10, for every system I give you, there will either be 1 solution, no solutions, or infinite solutions. In grade 10. Grade 11, there's more combinations. But yours is only going to ever be one of those 3. If it is 1 solution, I'm likely going to ask you to tell me what that solution is, though. Let's complete this little table to summarize it again for you, though. So if there is 1 solution, so that was the very first example we did, we have to have different slopes. That's the only way I'm going to get 2 lines that cross. They don't necessarily have to be parallel slopes. They just have to be different, though. So if I have a line like this, my second line could be like a very gradual slope like that. They're still only going to cross once. In order to have no solutions, the slopes are equal, but the intercepts can be different. Didn't say a word. Slopes just have to be the same. That's the biggest piece. Do you have this, Matt? Write your notes down. Oh. I did. I'm sorry. My apologies. In order to have infinite solutions, their words, we don't often use this, but they have to coincide or they're the same line. So you're going to have 1 line. So it's the same equation. They have the same slope, same intercept. Basically, same line written twice. We're going to try and squish in these answers below here. I apologize, they didn't give you a ton of space, so just do your best. So without graphing, that's key. You really have to pay attention to the reading, Andy. Mine's up here. Really pay attention to your questions because I'm going to tell you how to solve. If you solve it correctly, but using a different method than the question asks you, you're not going to get credit. So you have to make sure you're doing it by the method that they've asked you. So without graphing, analyze and determine whether the solution is 1, none, or infinitely. So to do that, you have to solve for y. So in A, so in the first example, the second equation, they've solved for y for us already. So that's nice. We need to solve for y in the first equation. So I'm going to subtract 3x from both sides, which gives me 5y equals negative 3x plus 15. What's my next step to isolate and solve for y? Go ahead, Matt. Divide by 5. And again, we're dividing everything by 5. What do you notice about the slopes of these two equations? They're the same. Do they have the same y-intercept? No. So that means the slopes are the same, so there are no solutions. For the second one, again, second equation, they've already solved for y for us, so that's nice. First equation, I have to solve for y. So I'm going to add 4y to both sides. Then I get x plus 8 equals 4y. What's my next step? Divide by 4. You're dividing everything by 4. So that x over 4 is the same thing as saying 1/4 x. 8 divided by 4 is 2. What do we notice about these two equations? They're the same slope. Who said they're perpendicular? 1/4 and 1/4. So I have the same slope and the same y-intercept. So it's the same line written twice. So therefore, it's an infinite solutions. Because I could plug in any x value into either equation, I'm going to get the exact same y. All the coordinates would work for both of them. Okay, this last one, we have to solve it twice. They weren't as generous on this one. So my first equation, I'll do in blue, I'm going to subtract 7x from both sides. So then I get y equals negative 7x plus 12. Second equation, slightly more work. So I'm going to subtract an x from both sides. So I have negative 6y, don't forget that negative, minus x plus 5, divide everything by negative 6. So then I get y equals 1/6 x minus 5 over 6. I have a different slope and I have a different intercept. So how many solutions are there here? doesn't matter if them both being positive or not. As long as everything's different, they will cross at some point. So what that means is there's one solution. It might be like not on like, it could be like way down the road, the cross, but at some point they will cross as long as the slope is different and your intercept is different. How is that? So right now, you know to solve by graphing, by literally plugging them into your calculator, by doing it by hand, and you can tell the number of solutions. When we come back from spring break, we'll go into the other two methods to solve. Okay, I'll stop there. I'm not going to give you this word problem. We do have some time to do some practice questions.
Save the line, Carmel. Save the line.